All right, welcome back, everyone. Hope most of you on the East Coast time zone have had something to eat. I am still working on my coffee and some voice break. Um, so for this session, which is for 75 minutes or so, hopefully will end in an hour. Let me get started and share my screen. And I want to make sure we have a couple of minutes of ramp up times for anyone who's interested in following along hands-on. So let's do the screen sharing first. Okay. Can you guys see my screen? Perfect. And hopefully when I go live with the full screen, you can still see that. Otherwise, let me know. And Dan, FYI, once I go full screen, I do not see the chat window at all. So just shout out if it's anything not working or any questions. Thanks, man. Okay. So the title is pretty candid here. Research that you and others can reuse and reproduce. And others could be anyone, like people who like your work or who might not like your work. So broadly, again, briefly, I'm Abhi. For those who might be joining new for this session, which hopefully is not true for most of you, and I'm the new independent scientist at KCNI, CAMH, and I'm going to be talking about reproducible research this session. Here's the housekeeping, right? So, and this also comes with a disclaimer that Dan already mentioned earlier, right? So I've spent last 8 years working very closely with Synapse team. So it's second nature to me. But I'm going to talk about other tools that you could use. This is just a demonstration purposes, and I'm not any more affiliated or being paid for this sort of work or showing this work today, just to be very clear. Yeah, so if you want to follow along this with some of the brief demos that I will have, or just wander on the interface and see what it has, then you can create an account. It's very easy. You just have to, let me even show that. I will be doing this back and forth today because it's going to be easier to show that. So you just basically register now, and you can use OAuth using the Google account if you have one, or sign up using your email, totally optional. That will allow you to explore publicly available data sets, or at least see what's available. If you are interested in uploading your data to Synapse, so rather than reading from Synapse, upload it to Synapse, that's where you will need to get certified. And the rationale there is the team wants to make sure they are accepting data from people who have gone through the due diligence and training and understand the pros and cons of sharing data and the risks associated with it. So it's technically a short quiz that I, in the past, have passed before reading the materials because it's common sense. But that might not work out for everyone because we are coming from different backgrounds of what data sharing might mean and might not. So that's the housekeeping. We will still have 15, 20 minutes before or more before we get to the actual demo part. I'm going to try, and this is not promising this, to paste this link for you in the Crowdcast, so you don't have to type it. Let's see. Call to action, share a link. I'm trying. Let's see if this works. Do you see something on your screen? Ah, okay. Well, I'm going to paste this in the chat so you don't have to type it. How about that? Because I don't know why the thing is not working. It's probably the heat of the moment. So here's the link. Once you create an account, and if you're interested and wondering where's the certification link, that you could use that. It's a little crazy to type it out. And with that, let's get started. Okay, so we will start where we left off the last hour, right? So various sources of data, data deluge. You have contextualization problem that one should be aware of, and how do you sort of bring in the disease specific, data generation specific, and environmental socioeconomic context to your analysis that I find very useful. We talked about some of the available data resources broadly that Dan mentioned, and then I went into very specific contextual data resources. And you finally have insights, right, that you love to share. And the way it works out is I'll draw an analogy which is somewhat overused in my presentations now. So maybe some of you have seen it in the past. Um, it's almost like you are baking or you're creating a new meal in the kitchen, right? And you are reading a recipe and you're trying to replicate it. More often than not, the taste or the flavor or whatever of the meal doesn't really match what the master chef thought it will be or said it should be. And the practicality in research works like this, right? So here is the awesome grad student or someone who took together that recipe or made a new recipe and published that in his research findings as the original paper. And that's awesome, right? I mean, that's the first great step. But as we all know, in order for research to translate into care, there is a whole slew of pathways. That means reproducibility, validation, external validation, so on and so forth, right? And parts of that starts from this sort of work, right, where the second grad student in the same lab comes and thinks, oh, it's actually not a cake, it's a slice of a cake that the other person thought was a cake. And then the lab too comes out and thinks, oh, this recipe is actually for a muffin. Whether it's a lemon poppy seed or a raspberry and whatnot, that's a different question. Pretty interesting though, but you get the flavor, right? The third lab comes and says, no, we can't really make a cake out of it because it's really, there is no, a key ingredient is missing, right? The eggs are not there or the oil is not there or whatnot, right? Or the oven is not there. We just can't bake it. And then the lab 4 says, it's actually not a cake at all. It's something else. It's a soup. And this is how the real world scenario is in research. I think one picture that is missing, to be fair to my peers and myself, is there can be case where the lab 1's third grad student can replicate it or a third lab can replicate it, which is an amazing part if it happens. But more often than not, we don't see it. And that should worry. And on top of that, we produce a lot of these insights every year. These numbers are almost a decade old at this point, and the frank reason is finding a right graphic to show. But it does not matter. These numbers have only increased in the last 10 years, not decreased. And now I'm going to say something provocative with all due respect to all my colleagues in my own work. And that's intentionally the way I'm stating it. So hopefully it's not misinterpreted at this point. I would say most of this is not useful for many different reasons, but I'll go by one peer-reviewed literature and few more I'll show that talk about 9 out of 10 or close to 8 out of 10 research that is not useful. And the useful is an abstract term here. It could have many connotations, and we'll talk about that. That's not good, right, by any means of imagination. But let's get more specific what I mean. Again, it's almost a decade-old paper at this point, but the concept and the findings are very pertinent, right? So Amgen tried to reproduce some of the studies. They were only able to do it for 11%, 1 out of 10. Bayer tried to do that for some of their interesting work that they were looking at in preclinical, and they were only able to do it for 1 out of 4. Here is more academic view on this. This is with respect to gene expression. Just picking the numbers from the figure. More than 1 out of 2 studies could not be reproduced by this group. And there are multiple reasons. Data not available, software not available, methods unclear, different results altogether. And you get the analogy, right? I was trying to give you a baking analogy there. that somehow the recipe is not able to produce what the original chef wanted it to, for whatever reason. And so what we really need is a more specific details on where is the source of this information. So who's producing the data from where? What is the version of the instrument that is being used to produce that data or instruments? The population, the characteristics, the software that was used to process that data, in what ratios the things were mixed, as in the parameters that is used to generate the data. As we all know, there are many parameters that software needs to process a raw imaging data to its potential features. And where it is available. How can I get access to that? I mean, you might have an amazing, awesome recipe, but if you are not able to get hold of the things that you need to produce that, you might just have to buy it all the time. And that's fine, but that's not what we are aiming for in academic research. Especially the goal is to get the initial findings to, interesting findings to care. So from an analogy to a more realistic perspective, we need to connect these dots, right? From the bench to the whiteboard of that researcher to its summary to an external lab that can reproduce that. It's the need of the hour for the decade, for whatever time point you want to bring up, but that's super important. And I haven't really even opened the Pandora's box on many different research. So I pointed at microarray. The same is true for MRI, neuroimaging, you name it, right? There is an art to a lot of what is being done, and that's fine, but we are not able to do a good job on setting up the breadcrumbs on what steps were taken to produce that recipe that is consistent, reproducible, reusable. So to our world, where the data gets created, where it is getting curated, and how it is being consumed by the original producers and its secondary, tertiary producers or consumers. I'm sorry, I meant consumers. So that's where I'm going to bring in Synapse. This seems like a marketing slide that I've used in the past. But the point is, think of this as a GitHub for scientific data in a very broad perspective. There's nothing special to it except that it provides a layer on top of data to manage the data's metadata and its security and analysis tracking. It's not a computing platform. So it's not Jupyter, it's not RStudio, has nothing to do with compute. You can run compute on top of it, but it's not a computing platform. It's a data management system, more or less. Like I said, there are many growing alternatives out there. There's DataVerse project from Harvard. OSF is the closest that I can find in terms of capabilities and mission to Synapse, Open Science Framework, and there are many more. And my hope is that the concepts that I'm going to talk about, whether broadly or in the context of Synapse, is not just Synapse specific. Hopefully you can reuse those methodology and sort of inform and guide your analysis. So it's basically to a point when you come back from your vacation or when I come back from my paternity leave, which has happened twice now, I can able to connect back the dots and see, this is how I actually made that figure. So here we get into the specifics. Creation could mean many different things. The data can come from various modalities, the machine that reads our DNA, so biological assays, to digital assays that we talked about earlier today. We need a way to crisscross digest this across the board. So system that is data agnostic, more or less, and could enable interaction with various computing environment, as well as real-time querying of data based on data provenance and annotations. I also forgot to mention on the last slide that the Brain Health Data Bank is in a similar spirit, although it has a more focused attention towards brain health, the stuff that Joanna talked about and clinical care. But it's also in the same spirit, like the knowledge bank where you can query. So the point is similar. And then how do you consume that? The data that you have just generated, curated, how do you share that with your audience? Whether it's general audience, scientific audience, through a research study portal, and its governance, so who can access it, the data annotation, so labels, whether it's the MRI data or PET data or it's wearable data, how it was produced, etc. So I'm going to get into most of these as a demo that hopefully some of you can follow along, or maybe more. So let's talk about creation. I'm going to be very brief here. The point is, and I will encourage you to go to synapse.org and explore that on at your will, but it has been used in the past for, and continues to be, for various kind of multimodal studies, whether it's to house bunch and terabytes of omics data or mobile health data, digital health data, you name it. And the point of this slide is it has failed many times, and that's good news. The system has been around for over 5, maybe 7, 8 years, and has been tried and tested in many different ways so that you could actually think that it works, and it actually works for real time and is being used by hundreds of researchers to do their real-time daily research using the backend. So how do we curate it? Let's get devil in the detail here, right? So this is a cartoonish figure, but I'm going to reproduce this in the demo shortly. So the goal is you have a new project, you need a parking space. Project has a name, Synapse will give it a unique ID. You can have metadata associated with that project, and then simply the lower half or the later half of this sort of picture can be looked at as there are folders, files, and tables where you can store your results. So one can think of that as an FTP, but it's not, right? I mean, it's more than you have layers of information on that file as annotations that are queryable. You have a real-time sort of a SQL database-like interface to explore that, and a corresponding wiki page that is associated with each entity. I'm intentionally not introducing a lot of Synapse-specific jargon today because that's not important, right? But the point is, I have a project. I need to park data with that project that I can access on demand through my compute environment. That is it. Anything else on top of that is bells and whistles, right? So let's get started. I'm going to demo a Synapse Python API, and this might go right or wrong depending on the audience preference, but I've chosen this path today. Some people like to get a visual overview of Synapse first, but assuming the audience here is more techie and sort of oriented towards research, I thought you guys might be interested in the devil in the details, sort of show me how it works and how it doesn't, right? So we're going to do it slowly. We have plenty of time. So let me make sure you guys see my screen. Can you see my screen? Okay, great. So I'm going to be as verbose as possible, and if it's too much, then it's better than having less, hopefully. So Jupyter is just a compute environment that some of you might have been already exposed to. You can run line-by-line Python queries and even R. The demo today will be, one is Python-based, that's the entry point, but I'm also going to show you a more crazier R-based demo later. And just to drive home the point, this is simply running a Python code, nothing else, as simple as that. And then I'm going to now show how from the command line, so command line or Python, right, into programmatically, I guess, you can interact with Synapse, create a project, push the data, and so on. So we'll look at that. There will be certain areas that I'm going to intentionally gloss over because the point is not to get into the gory details of this function or that function. So I'm assuming you guys have seen this link, but I'm going to make sure it's in the chat because I'm not able to work out the other one. So here is the link. This link is going to take you to a GitHub repo. Right there. I'm just running it locally so I can actually execute it, right? So just want to make sure you are on the same page with me and can look through this if you are interested. So coming back to my live coding session now. Okay. And if you're wondering, this is where I'm hiding the details intentionally. So there's a lot of utility functions that I'm going to use to make my job easier and sound like I'm doing it in a single line. But that's to make sure you get the functionality of it, in the essence of what it is. And if any one of you is interested, like, oh, this sounds too good to be true and what's going on here, then some of the utility functions are basically found in the same GitHub repo. So if you go from here to the Python, then you see I have this, where is it? Demo utils function. So it's a more involved code that I'm not going to talk about today, but it's all there, and there is no secret to be doing this. Okay. So the first step is I'm loading the Synapse client. So this is a Python module that I installed priorly. You will need to install it. And then I'm pulling back some functions to create. Remember these things, a project or a folder or a file or a wiki. That's what I'm doing. And running the utility functions. This is the quintessential step to establishing your identity and logging into Synapse. The reason you see blank is I do not want to share my password here. So I have saved it locally, and it is smart enough to know if my password is saved locally to just log in from there. So I did not run it right? This is going to be really interesting now. So I don't have any of this working as normally the demos go. So it seems like my environment is not set up. So give me just 1 second. No demo can go without failures. Okay, so fingers crossed. Otherwise, we have a static notebook to look at, which will be a shame. Okay, let's see. Okay, that should work. And just so if you're wondering what did I do, I have various Python environments, and the one that I started was not the right environment for this project. And when I say Python environment, I mean the Python installation, which has various submodules. And in this environment, I did not have the Synapse client installed. That's all. Okay, so the first thing, I am interested in creating my project. It is a cell line analysis. It does not matter. It could be a depression severity project, but the point is I want to create a project. Here's the name of the project. I'm choosing a random word so you can rerun this code anytime. And I want to store that project on Synapse, right? So you create it locally and then you store it on Synapse. So let's try that. Here is my project ID. I can very quickly click on show me the project. I need to log in, right? Because it's not a public project. So I'm going to log in now. And here is my project, cell lines. This is the random word. So let's connect the dots. Here is the project unique ID, syn25 blah blah 553. And here is the project ID that was just created. Simple. You can also create the same thing from the website. So it's not going to, so let's do that. Rather than working from the command line, I am interested in creating a project from the website. Create a new project. Test KCNI summer school. And here's my project. Here is the Synapse ID for that project. And by the way, just important to highlight, all of this is currently available for free. I have no insights whether it has been available free for last 8 years or so, and I don't think Sage had any intention of charging for basic services like this, unless the plan for someone is to store terabytes of data, because nothing is free, right? Okay, back to the point. You created this Synapse ID. You can do the same thing. You can say, just to prove the point here, you can use that Synapse ID and go back and come back to this project where you are. So right now, this project is blank. There is nothing on the wiki. You obviously have the file folders, nothing here. You have tables. We're going to talk about it later. You have a forum. So this is a forum where you can discuss anything regarding this project. So that's all available for free. And you have a Docker repo that you can connect to this. So any of the code that is run for the data that is produced or consumed from this project could be attached via Docker through this page, which is amazing, right? It's like all the paraphernalia potentially that you need for bringing together your analytical tools in under one roof, but not the compute environment. I'm going to take a quick break to make sure there are no questions. I'm fairly spitting a lot of information towards you. Okay. Once again, my intent is to cover less, but to cover in a more manner that you can at least comprehend something out of it. So if you are lost, please let me know. Okay, so we will proceed. And now I'm going to say I want to create a wiki for my project. So programmatically, that's important. Here is that. And then I'm going to add some text on this wiki. So again, I'm not emphasizing the markdown syntax or how do you push that. I'm just displaying the capabilities here so you can see what it can do. So let's go to the right project because I was crisscrossing between different projects as part of my demo. So this is the right one. So here is your wiki that is being created, and here is the cell line growth look normally distributed. This is like your finding that you are saying here without showing the findings itself. We'll get there. The point is you can programmatically manage this wiki for your collaborators or for anyone who is part of this project. Moving on. Now that's where you want to store data. So you want to organize your project under some folders. You want to store results under your result folder and data under your data folder. So you basically initialize a folder object and you store it. Simple. In a file sense, you initialize a file object and you store it. So let's do this quickly. And by the way, this could be anything, right? TSV, CSV, JSON, you name it, right? Synapse doesn't care. At the end of the day, it's all going on the cloud somewhere. Okay, so I'm going to close the extra projects here. So coming back to our demo project. So here is my results folder, and here is my cell line. There has nothing in there, right? So you can get a preview, and there are various other things that I'm not going to talk about. And then you can also download it just from the web client, or you can download it through a list, and that will work also. So at this point already, just recap. You have a HIPAA-compliant free workspace that is available for you to manage your data. You obviously have to adhere to your data generation guidelines and IRB requirements. So I'm not suggesting you put your data right away on Synapse. That's not the point. But assuming it's okay with your IRB regulations, you can do that. And you already have a place where you can store a file or files and whatnot. And suppose I want to analyze, I have analyzed some data and I have a plot that I want to add. So it's the same thing, whether it's a plot or a data file, the concept is same. You are still uploading that plot as a file as far as Synapse is concerned. And if I run this, it should again land in the same place. So I have my plot here. You see a preview of it. You can go higher, etc., etc. But what it doesn't show so far is who created this plot, what was used to create this plot, etc. I mean, yes, you can see I uploaded this. This is my user ID and the date and time provenance, but not a whole lot of details on the scripts and all that. So essentially, this is what I'm trying to show. What data was used to produce this, what code was used to execute this. So let me walk you through this. I have my raw data file. This is a Synapse entity. That's why this is a Python object. Here is the code that was used. Again, dummy values here. Here is my plot. So I'm going to say store this plot and then mark in the system that I used this data, which was just instantiated here. And then I executed this code. So pretty simple Python stuff. A file object for Synapse, what it used to produce the data, the plot, and the code it executed. So just a couple of additions. Then if we go back, here is my plot 2. And now you see the difference. Here's the plot, but here's the difference. You can now see this plot was created using this as the cell line blah blah raw data using this code generated from GitHub. It's of course all dummy, but you get the point, right? And who produced this? I did that work on right now. This personally has been useful to me when I am producing pictures, images for a manuscript that I'm going to talk about later, to just statically snapshot it here. So it's very clear what happened. There's no second guessing about this. You, of course, can have a specific commit code of version of the GitHub and all that stuff. So I'm not getting into all those details, but all that is possible. And then you might want to show these plots to your collaborators on a wiki page. So now we're talking about a project website, but don't think of this as the fancy website. This is just basic stuff to show your research internally or externally if you want to. So I'm using basically telling Synapse to use the same locations of the plots that I have underneath the results folder and then show it on the wiki page. So hopefully they will show up here. So that's done. And here are plots. These are not duplicated again. These are just showing up as a web view from the original file location. And if you click on them, you will reach exactly where you should. So going back and clicking the second plot. Sorry for this message. The reason is I'm not anymore part of Sage. So they are telling me again and again to please change my damn email ID. One day they probably will close it. OK. So again, if you click on that plot, you will now see the provenance associated with it. So it's all sort of integrated. And if I go back to the slide to just contextualize it visually, you create a project, couple of lines. You have a way now, you get wiki space for each project. You can upload your folders and organize your data. You can also say which file produced which file and what plot was produced using what kind of data and where the code is coming from. So nothing fancy. It's the glue between your data and your analyses, and then track it all together in a open source way that is fairly secure and tractable. Okay, any questions so far? Great. Either this is a post-lunch nap time, or am I doing too well, which I really, really doubt. Okay, I'm going to take the bait and just continue here. So now we are going to get into more visual demos. So we talked about broadly creation, which was just saying that it can support curation of any kind of data. And I showed you a way to create a project from scratch, uploading files, provenance-based graphs, etc. But you might want to say, I am not interested in any of this. I just want data so I can do my own analyses. So that's consumption, right? How do I consume data from Synapse? And I'm going to show you some examples now to get into that detail. So here is a relevant one. I'm going to keep it a little brief only because this is unpublished data, but that's okay for this audience as long as you don't start tweeting this right away. So these are Brighton studies that I talked about earlier, right? So they have been published, but the raw data has not been available. But same project, right? So I have created a project. I have a wiki associated with it. This looks a little more fancy, but the point is you have a wiki. I have nothing in my files. So you would wonder where the hell is the data, because we have used another feature called tables. So instead of storing files as CSV objects, we have stored them as interactive SQL-like tables. And this might sound familiar: PHQ-9, mental health services, GAT7, etc. So let me open something obvious. I'm going to open sleep. So you have your participant ID, the date the response was collected, and the response to sleep question number 1, 2, 3, and 4, so on and so forth. And here is the provenance. This is beautiful as far as I am concerned. I don't know if you will appreciate it, but I'm going to demonstrate that to sort of see how do I, well, I think it still conveys the point. So and so. So that's the person who worked with me back in the days created this final object using raw data. Here is the IPython notebook that was used. So bang on, right? This is the exact notebook that was used to produce this data. And here are the two data formats we used: a version 1, a version 2. We did some munging and created this final data set for release to the community. So it really, there's nothing rocket science there. It's just tractable data management that makes it easy. I can very easily do SQL-like queries on this, and I'm shying away because I haven't done this for a while, but let's see. So now I'm getting distinct participant IDs. I think there is a way to do counting on that, which I'm not going to attempt, but you get a sense of what I'm trying to do here. So here are all these ways of setting up these search columns. Maybe, I don't know, let me give it a try, but I'm not sure how good I am with this stuff now. Yeah, my query is not super strong. So, but you get the point. It's a very SQL-like interface that will let you query your data fairly robustly. One thing I can potentially do is, let's see if this will let me, and this will be the last embarrassment I will put on me. Where? So I'm trying to query for a certain particular participant. Let's see. One more try, and then I will not embarrass myself further. Okay, that works. So you can do, of course, all of this programmatically in the Python or R client. I'm just showing you what you can do on the website. So backing up, we have a Brighton Study Researcher portal where we have collated all the information about a digital health study that was run in the last couple of years. Everything is available here in terms of participant raw level data, cross-queryable across the board. And let's see if I can show you more. And this is the magic which lets it to be cross-queried. So this table has certain annotations, and it's almost like a NoSQL database at that point that you can query across the board. So without further details here, let me recap what it means for you. As a researcher, you can now come and consume data from this portal, assuming this portal is available to you. And I'm going to show you another example. You can look at the data description. I forgot to mention this, right? Each of these tables have a corresponding description on what it means. Here is the column table. So that's where wikis become really useful and powerful, that I click on the table, go to the table, but here's the corresponding description. So it's tied together very nicely, allows for full LaTeX sort of work here. So it's a nice sort of handy one-on-one mapping to what your data is and what's the metadata around it and what's the provenance for producing that data. Okay, so that's one example. Here is another one that is worth highlighting, and I'll tell you why in a minute. So this is one of the first flagship studies that Sage back in the day ran with Apple, the launch of Apple Research Kit. 5 years ago, no, actually 8 years ago. And it has had a massive interest and uptake by research community. There are, I think, more than 300, 400 citations by now for this work. So again, the point is a project, various metadata associated with what was done. You can also embed YouTube and all that. So it's pretty fancy in that sense. You have data descriptions that you can figure out, similar to what I showed you earlier. Here is the data available. There's a lot. So these are sensor data. So walking activity voice. I'm going to show you one in a sec. And the reason I am able to see this data is I have approval. When you create an account and go to this link, if you happen to, which I doubt, you will not be able to see the data. You will have to go through this. This is an intentional frictional exercise. We have introduced friction in order for researchers to access the data, because we need to verify who you are. Do you understand what role you play? Do we understand what role do you play in your institution? Do you understand the roles and responsibilities for handling this real-time participant data from hundreds or thousands of participants and potentially identifiable data? So you have to go through register for account, as I said earlier, become a certified user, and have your profile validated. So entry point, gate 1, gate 2, and the profile validation is to make sure you are a qualified researcher to access this data. I'm not going to read any of this, but you get the gist. These are intentional barriers, friction, whatever you want to say, to make sure you are the right person to be accessing this data. And once you get that, you will be able to see this. So let's open one activity. So tapping is one activity that is a sensor-driven activity. Participants with or without Parkinson are tapping on the screen, and the point is to see basically some of the neurological disorders and how the hands are shaking and all that sort of stuff, and various other constructs of Parkinson's disease that I'm not going to get into. But the metadata is beautiful, at least to my eyes. You see your participant ID, created on, app version, which phone was used, and blah, blah. Lots of things there, but this is also very sweet, right? So you get access to raw data, and this is live connection between a smartphone app which is deployed in the wild and the data that is being collected here. So I'm going to try and download one. This is nothing fancy, but I just want to show how easy it is to sort of look at this data. Now I lost my download link. Okay, it's interesting. Okay, 1 second. I'm opening the downloaded file for you. Give me just 1 second. Here it comes. So here is that crazy amount of data, real-time, time series interval data that you can collect on tapping. And it's essentially what coordinate on the screen they are tapping, the time step between tapping, etc. And there's a slew of research on this in terms of the varyingness in the tapping interval, how it's related to the bradykinesia or different kinds of neurological deficits in Parkinson's. So this is where the devil meets the details, or the rubber meets the road. I'm mixing them up now, of what exactly is for this sort of research. Okay, consumatory example number 2 is Empower. I'm going to skip the other one. So we talked about this, right? I showed you sample data, what it looks like. I think Dan was showing this earlier. So these portals are built on top of Synapse. And they basically, let me open this very quickly, assuming this has access for me. So what you saw was the Synapse interface. But these are more fancier interface for leaderships and even for researchers to explore the data that still is living on top of Synapse. So, and all of this is open source, right? So you can access this website code and create a similar website for your own purposes using your own data set that you curated on Synapse. So if I open any one of this project, it will tell me people, data. And it's all pulling real time from Synapse. There's no magic to this from anywhere else. Let me see if I can show you that very quickly, which might, yeah, so these data have been released. If you click on that, now I'm sort of getting into the details here. Anyways, this is not my project at Sage, but you get the point. These are one level higher up sort of websites or portals that allow you to browse that data across the studies rather than within your own project. Okay. Let's see. I think we have covered enough of this. We talked about this earlier today, so I'm going to skip it. And now I mentioned this, right? So what about tractable analysis? Can we get more specifics on this? So this is a picture that was created. Let's see if there's, so a couple of years ago, right? And this actually is part of a paper that is in press right now. But you see the point. There is a notebook that is stored on Synapse, so it supports storing your IPython notebooks, although that's not the intention. It could be any file. And then it shows how and what work was done. I showed you this, but I'm going to show you in more gory details because this is more complex analysis. So going back, Larson produced the subtyping file, which used the output from Megasham, my prior colleague, who processed data from different files that in turn were produced by, why am I going back? By Tanir. And you get the picture, right? So these are complex analyses that require feature engineering, raw sensor level data to be processed by another person, and then the machine learning person comes up, and then the clinical person comes up. So you have this hierarchical sort of knowledge graph. I don't think it's a knowledge graph per se, but you get the point, of relationships between what was done by whom, when, etc. Super powerful for larger code base and for collaborative work. And then you have the GitHub integration with the Docker, so you mix them together, and that could be linked to the project itself. So I think I made my point there. I'm going to skip this. So the last bit, and I'm doing a time check on this. I think we have half an hour more. Is that right, Dan? I think while I'm
just unmuting. Yeah, so the next session starts at 2:45, and with the 15-minute break, that gives us half an hour.
Awesome, thank you. That's taking more than I expected. So we are the last end of it, right? So just to recap so far, we went over why reproducible research, what can Synapse do, and I showed you an example of setting up a project in Synapse and the basic underpinnings of file storage or storing a plot with provenance, etc. Now I'm going to get more real time, and unfortunately, I don't think you guys can reproduce this on your side, which is quite an anomaly and quite an opposite to this discussion, but I'll tell you why, and that's important. So let me paste this link. At least you can look at this notebook if you are interested, which I'm going to show you anyhow. So there's that. And then this should sound familiar from the morning conversation. I was talking about this paper of mine where we did some research on understanding who gets to stay in these studies for how long. And these have a lot of survival curves, and that's a lot of data to be sort of putting it all together. So I'm going to try and show how I used Synapse for managing the code workflow and how that was distributed to the community to be able to reuse it. So this is practical sort of implementation. If something doesn't make sense, it probably doesn't make sense, and you probably need to tell me that, because it's just from my viewpoint and not necessarily from your viewpoint. Okay, so let me close all of this. Let me show you from your perspective what you might come across, and then we'll walk it back from there. So here's the paper. The point is not to show the paper. The point is to show you might be interested in this research or just wondering, this cannot be true. I want to reproduce this. I want to make sure this guy is saying what he's saying, right, in the right way. So you will go to the section data availability. You will look at this. Data is available. Let's see what it is. So we will click this link, and is the code available? Fantastic, even the code is there. So we will open this. So this will go hand in hand, right? Where is the data? Where is the code? Oops, I pasted two links together. That's not going to work. So if I was too fast, I am opening two things from the publicly facing paper. Where is the data and where is the code? So here is the data. That I think you can open now, even if you don't have credentials, because this is publicly available project. So I'm posting the link here for the curious. And this shows all the data that was used for generating analysis for this paper. And the concept is same project, file structure. And we are using folders to store our data this time, not tables. But this is how I did the work a year or two ago. And then the second thing I want to show you was, where is the code? So this is the code that should be able to reproduce anything for this paper. So let's focus on one graph rather than everything here, right? So going back to the code. Okay. So let me contextualize this. I am now in the Jupyter notebook for R, not Python. So I just want to make sure it's diverse between R and Python. I'm going to now show you how we could use the data that's publicly available after getting access to the data through your governance mechanisms and whatnot. But it's available to produce this data. This is essentially housekeeping stuff for setting up the Python the R infrastructure, and loading the packages. I'm not going to belabor on this today. And the code is available if you're interested. These are all the warnings. We can ignore that. And I'm loading the data now. I'm connecting to Synapse as we did for Python. These are just hard-coded study colors to match the expectation of the journal. So why am I going crisscross on this? Sorry. These colors. So there should be 8 numbers, one for each color. That's all that's going on there. And we get to the business now. So the first program command is to basically give me all the engagement data for the first study. Remember, there are 8 studies in this meta-analysis. And I am saying, give me all the data for Empower study. And let me remind you, this data is available, but if you run this code, you will not get it right away unless you go to the corresponding project of this data and get the permissions. All of that information is available here. I fully understand. It's a lot of information being spit at you, but the gist is I'm just trying to show how you can create similar backend repo for all your projects, whether on Synapse or whether in Open Science Framework, it doesn't matter. So it's tractable. You can be proud of that work and show off it to later people to say, this is exactly how it is, and good or bad. So this is going to be real time pulling all the Empower data that was used for the survival study here. So let's do that. Seems like it's over, and let's run this. So here is the data, study name, participant ID, which is a health code, and the demographic data. You can also look at the engagement data. Now, I am not talking and defining what these columns are, what they mean, but it suffices to say this is the raw data at the individual participant level that was used for generating plots on how long each participant stayed in the study. That should be sufficient for this context. And so we did this for one study, right? Now we have to repeat this for 8 studies. Here is the script that does that. There's no point for me to actually do it all over again. I'm going to press this button. It's likely not going to complete, so I have a backup data folder for this. But let's give it a try, and let's see, maybe it will embarrass me and fail here. So while this is running, let me give you another insight that might be helpful. So I will let it run. We'll go here. So if you're looking for a good practice, I would highly recommend this. So each time I start a project, regardless of whether it is on Dropbox or Box or Synapse, I always will have a standardized script for loading data. So that way, you, your collaborator, your PI, your peer, all are loading the same damn data. How often we have come across the place, oh, I cannot reproduce your plot internally because my data set has 500 less rows than yours. That is just, it's realistic, it's challenging, but it is completely avoidable if we all share the code for a single loading of the code. This is not analysis. This is just saying each one working on this project will load the data exactly same from exact same location. It could be Synapse, it could be anything else. So remember the single data I showed you for Empower? It's the same story. Study one, let's zoom in a bit. Here is Empower study, here is the start study, and so on and so forth. You go on and on, repeating the same, so there is recursion here. And I'm going to spare you the details now, but my point is that's how I would recommend doing any reproducible analysis, to at least have a clean slate for using the same data that everyone can use. So without confusing you further with all these gory R commands, I'll close this. And as I expected, this is going to run for a while. So I can give you maybe 30 seconds if you have questions. Now's a good time. Or I will cancel this if you don't ask a question and use the data that I have already curated. That way you will not be able to see if it works or not. Your call. That way I get a break as well. Okay. My gosh, I really hope that I'm not overwhelming all of you there at the end of the day on your side, or nearing the afternoon. I'm going to stop this, and then I'm going to load it from the pre-computed environment on my side. But I hope I'm able to convince you that this is still running. It's not failed. It's just doing its job. And it is amazing that with a click of a button, with a script that comes along with the paper, you can completely recreate the raw data environment, provided you have the governance access to that data. I think that's a very powerful thing if you can do that for future research, regardless of what platform you use. Okay, I'm going to stop it now. You lost your chance. Okay, so let's see if this one will work. I'm just going to load this data from the local dump. That should be quick enough. And just to recap, I am just reloading the data that I stored previously last night, so we can quickly reproduce that plot. This data is going to, if I do for the R users out there, it loaded a bunch of different things. I'm not going to exaggerate and overgo on each of the things, what has been done here, but you get the point. The script that was canceled right here would have done the same thing in real time. So I'm now going to load some bunch of packages for doing survival analysis. And here is a stratified log rank test using the data that I just uploaded. So one thing to note, here is the number of data points in this data, 95277. I don't know if this is exciting for you, but it is exciting for me to be able to get there. And that's the number of points that is there, 95277. And it takes a while to get there. We took a lot of time to make sure this is sort of reproducible to the best of our efforts we could. So that's what I'm trying to demonstrate here. We loaded the data. Yes, I pre-computed it for you because we don't have time to go through all the data loading right now. But if you can trust me on that, then you have the exact same data being reloaded. And now we will use this to create the same plot. It's exactly the same thing that you see here, except that the legends are inside. So And the p-values are all taken from the log-rank text, which we can, it's not relevant right now. Here's the p-value that was generated. Okay, so quick recap. We talked about a lot of things here, but the essence is you found a paper, you like the method, or you question the method. Either way, you are interested in replicating or testing what it is, then you can make it work for your audience and give that confidence by creating a folder where you store your code, hopefully GitHub. Folder is just a similar, using the analogy there. And then you can use Synapse-like infrastructure. It could even be Dropbox. Don't get me wrong. Dropbox can give you a unique link, but it's not the most efficient way of doing it. But you share with your audience, here is my data, here is what you need to do to get the access to the data, and here is my code, and here you can reproduce this. That is super needed, important for our field if it needs to move beyond, here is my research and here is my paper, but guess what? Here is my cake and here is my muffin. It does not work. Cakes and muffins do not align each other for robust, reproducible findings that could have clinical impact. So hopefully I've made my point here. I'm going to stop screen sharing, and we still have some time for questions if there are any. Let me stop this. Okay. And if not, Aaron can post the gather down link. I will try to hide in a secret room if you want to have a one-on-one conversation, if that's of interest. I'm a little bit worried that we did not get questions here, but I hope at least the concepts were clear. And if not, blame it on me.
I have a question. So I'm curious because, looking at this, and it's really, like, it's wonderful. It's like the ideal situation. You have a data set that you can push up to Synapse or somewhere else and keep it totally separate from whatever secret sauce is going on inside your own server, and then have your code available. Like, it's really striking. Like, you don't really see that kind of reproducibility. Often you can reproduce a finding, but to have it like the code posted. And I also notice now it's a trend, especially in more computationally oriented journals, to allow digital submissions themselves. So like you submit the code. We saw like a paper the other week that was pure code. The whole paper is just code. So like all the text and everything in the paper is code. The figures are generated. So it's like, I guess I'm wondering, do you think that in the not so near future, that's where everything is going to go, and not just in a digital health field, but across like all biomedical fields? Is it practical? Like, is that basically where all research is heading? Like now we're doing this computational, neuroinformatics is important because data are so big, you need to be able to do it. But like, is the era of anything less than something like this totally over? Like, is it you have to know it or learn it?
Trying to unmute myself. Can I give you a standard answer? Yes and no. But let me tell you why. I think not every data should be shared, and I'm saying that responsibly. And I'll give you an example, right? There is a whole slew of research on findings from real-world data from EHR datasets. You cannot leak them or share them, right? In whichever way possible. But here is the other side of it. There are multiple ways to make it work. So the goal is not to highlight SAGE here, but people are not talking about what can be shared in the governance structure. And I showed you some examples. Digital health data potentially, genomics data potentially, with severe restrictions on you will not attempt to re-identify and all that. But you can also do, so that's data to compute. You bring your data to you or your cluster and you do something with it, right? And all the things that we showed earlier this morning, Dan, are sort of on that horizon, right? You apply for access, you download the data, hopefully on your side or a cloud cluster, and you analyze it. There's the other side of things, which two sites are getting super interested and involved in, and one that is the medical centers. So this might be of interest to CAMH, where they are bringing compute to the data. So the data never leaves the premise, and people are shown a structure of the data. Data is in a standard structure, and they can run their algorithms on the data. We have done this multiple times at Sage, where we worked with medical systems who we ran a $1 million competition with Avon back in the day with mammography. So mammography challenge or whatever it was called. And participants were given access to millions of mammograms, but they were only allowed to compute on the data within the DMZ or the closed environment. And they only get out certain factors or like predictive matrices from those things, but not the actual data. So that's idea number one for sensitive data sets, right? Where you can still say, yes, you can recompute anything I did using my own code, but you have to run it within my house. I cannot allow you to run it on your side because of X, Y, Z. But I think given the audience here, the take-home message is, I think those days are gone where you say, and I hate some of the conferences that do this, here is my super awesome deep learning analysis, no idea where the code is, no idea where the data is, but the analysis is super awesome. It doesn't stand the test of the time. I'm not disrespecting any researcher there whatsoever, but we have seen this time and again that your one parameter that you decided while sipping your wine or coffee might not be the best or might be the best. And unless you share it in that devil in the detail stuff, it will not see the light of the day, whether it's a failure or whether it's application in the clinical care setting or real life impact. I think Akshay has a point, so let's get to that. I feel there is also a challenge of ensuring the use of standardized workflows, well-commented code and software alongside data to ensure reproducibility. Absolutely, but I think that comes once you have something. We are at the phase right now where there is struggle, and I can point you to many resource papers or white papers where so and so many researchers reached out to hundreds of researchers to collect the data from their papers, and they heard back from 10%, and then the data got shared by 5%. So we are still in that space where asking for data and begging for the code is still the norm. And I completely agree that the next step is, okay, now I have your damn code. How do I even run this monolith or something that I don't understand? And that's where Docker and CWL, the languages that help you reproduce the standardized workflows through Amazon or Galaxy and whatnot. There are plenty of open source solutions that allow you to specify completely end-to-end reproducible workflows through Docker and within R or within Python, etc. So a great point, Akshay, on that.
This might also be, just in a couple minutes before we give everyone another break, a chance to answer the question from the previous session when we kind of ran out of time, which was, I believe it was also Akshay, who was wondering, how does the fact that a significant amount of genomics research happens today in companies impact data sharing? So kind of getting at how things might used to have been, where it was usually data generation and sharing from universities, and now public-private partnerships, kind of how has the emergence of public-private partnerships and private companies getting data affected the data sharing landscape?
Yeah, that's a great insightful point as well there. I think the short and the candid answer is this. Pharma has collected so much data over the last 50 years of their research across many clinical trials. And they're finally realizing that once they extract the juice out of that data for what their intensive needs are, good or bad, and whatever the internal capabilities are, they are very clear they lack all the abilities in the growing ML research world, and they need to partner. And they are working on various mechanisms, right? So without naming, because it's still with Sage stuff, there are multiple pharma that are exploring potential data to compute to data options, where they want to invite researchers to use their data that they have collected over the years, but use it in a responsible manner so the data doesn't get outside their premise, but people can still compute on it. And it's a gray area still. There is also consortiums being formed. I can't recollect the one that I want to share, where pharma is now sharing bunch of data sets from their prior clinical trials in a singular repo. Sorry, I can't remember that right now. If I do, I'll post a link. So I think the trend is changing, but it's changing slowly. And now there's another mess that is happening. So now pharma is getting big time into sensor-based tracking for certain disease areas, especially neurological, because that's where the technology is most ripe, and mental health, but there's not a lot of pharma working in mental health, where they are now thinking of that as the new oil for them. And so now they are starting to amass a lot of digital health data that they are reluctant to share. So there is also growing. So Roche, for example, is a great example. They have collected so much data over the years, but in the studies that they're running, but it's not broadly available. But you can understand the rationale behind it for now.
I can add to that as well in terms of companies and data and public-private partnerships. A lot of the private companies are very keen to access the expertise of the academics and the major academic research centers. So there is a flow of money. I mean, it's of interest to both sides. So in my experience, researchers have been very interested in partnering with private companies because they'll happily give them money to run experiments, and all they have to do in return is kind of run analyses that they'd like to do anyway. Of course, it benefits the pharma company, and in the big circle of things, that might be beneficial to people in general, because many of our labs and kind of academic groups don't have the resources to actually translate any of the models or the findings, into practice. But on the other side, on the major big companies like Google and Facebook, social media companies, 23andMe, that collects a lot of data from a large number of people who volunteer for research purposes. They're not they don't play by the rules of these other NCBI government-funded agencies and kind of major research initiatives. They don't feed into dbGaP. They don't make their data available through these types of reproducible portals. They have their own systems. You have to kind of go to them with very concrete proposals and try to get ask for access to the data. It's not a common route. They kind of exist separately, in that sense. So I don't really know if the kind of increase in private companies collecting data from your devices and your online activities and everything else has actually played into data sharing for research. I think it's just created another possible pool of data to access, but they're not in the mainstream of research. They've been kind of sometimes frustratingly separate. Mm-hmm. Sorry, Abhi, you're going to have to unmute there.
I was just saying it's time to probably wrap up, I guess, right? We are 2 minutes, maybe 1 minute away at this point.
Yeah, I mean, if there are no further questions, then we can take the break. We'll be back at 2:45. I'll be back at 2:45. And there'll be even more science. I'll come back to talk about kind of personalized medicine and intro into what's going to be the very end. I get it's the blessing and the curse of kind of going last and bringing things home to the final day, which is tomorrow. Tomorrow's a half day, really. Tomorrow morning, I'll talk about some methods and examples of integrative methods and models. And then we'll have a group discussion. Everyone will come back. Abhi will come back. Joanna will come back. John, Itai, the whole group, Aaron, and we'll be able to kind of chat about all of the levels that we've heard about over the last week and a half. But I'll be back in half an hour to talk a bit more perspective on precision medicine and kind of start introducing some of these holistic models. And thank you for the enthusiasm. And thank you, Abhi, for that. Really awesome. I'd never seen a tutorial that kind of good with accessing that. I mean, it's striking. I love seeing that plot like come together, and a really clear example of how to access Synapse. I hope at least some people were able to set that up. It is very quick. You know, it's not like a lot of sites you go to kind of create a ghost account and you spend 10 minutes, you know, with push notifications and checking emails and verifying and linking your ORCID and everything. You can kind of just set it up and get working on it. But
I'm going to set the recording of this video too.
yeah, I thought it was great.
Cool.
And I know everyone appreciated it. Great. Okay, we'll see you back here.